So in chemistry, we're going to be looking at acids, bases, and salts. We'll be looking at acids, bases, and salts. So for this topic, we are going to look at acids on their own, bases on their own, and salts on their own. So we are going to start with acids. So from the word acids, we usually consider that when we hear the term acid, which means we hear something which is dangerous, but that is not always the case. In fact, we usually use acids in our daily lives. For example, ethanoic acid, it is used to give vinegar its sour taste. Then citrus fruits such as lemons, grapes, and oranges, they contain citric acid. And you know that me and you, we usually take lemons, grapes, and oranges. Then the dairy products also contain lactic acid, such as sour milk and yogurt. So acids are not always dangerous substances. We usually use them. We usually use them. So I said we use So acids must not always be treated as dangerous substances. So we use them. For example, ethanoic acid. Ethanoic acid is used to give vinegar its sour taste. Then we also know that the citrus fruits such as oranges, lemons, and grapes contain citric acid. We also use the dairy products which contain lactic acid. So the dairy products contain lactic acid. And the dairy products include the sour milk and the yogurt. So let us now look at the properties or the general characteristics of the acids. So let us look at the characteristics of acids. So the first characteristic is that acids have a sour taste. So acids have a sour taste. Then the second characteristic is that acids are corrosive. That means that strong acid can damage your skin. So acids are corrosive, and that means strong acids can damage your skin. Then the other characteristic of the acids is that they are neutralized by bases. So these are neutralized by bases. So these are the general characteristics of the acids. Let us now look at the definition of the word acid. So the definition of the word acid is that an acid is a substance that forms a hydrogen ion when dissolved in water. So this is a substance that forms a hydrogen ion when dissolved in water. So this is a substance that forms a hydrogen when dissolved in water. And when the acid is dissolved in water, it forms a aqueous solution. So an aqueous solution is formed. So when acid is dissolved an aqueous solution is formed. Then the other thing that you're supposed to know on acid is that all the acids that we use in the laboratory, they're in form of aqueous state. So the acids that we use in the laboratories, so acids used in the laboratory are in aqueous state. And some of the acids that we find in the laboratories, we have hydrochloric acid, and the chemical formula of hydrochloric acid is HCl. Then we also have sulfuric acid, which is written as H2SO4. We also have nitric acid, which is written in this form, HNO3. Then we also have ethanoic acid, which is written as CH3SOOH. So these are some of the acids that we find in the laboratories. And so when an acid dissolves in water, it ionizes to form a positively charged hydrogen ion and a negatively charged ion. And we write the general formula. I'll write the general formula. So when an acid dissolves in water, it ionizes into two forms. It ionizes into a positively charged hydrogen ion and a negatively charged ion. So when an acid dissolves in water, it ionizes into two parts. So the first part is the positively charged ion. So I have positively charged hydrogen, positively charged hydrogen ion, and a negatively charged ion. And this can be represented by using a general equation. So we'll write it in this form. We'll just write it in this form. Hx is equal to, so this will give a hydrogen ion which is in aqueous form plus another negatively charged ion which is in aqueous form. So this is the general equation that you need to know. So I'm going to write that general equation again. So it is Hx. This will produce a positively charged ion of hydrogen which is in aqueous form plus a negatively charged ion which is negatively charged. So there are some of the acids that we can write in this form. So we have hydrochloric acid. So for hydrochloric acid, when it ionizes, it will be in this form. We have hydrogen will be positive here, which is aqueous state. Then we also know that hydrochloric acid is in aqueous state plus the chloride ion which is negatively charged. So as you can see from the general equation, we had Hx, so this is hydrogen and X. It will produce a positively charged hydrogen plus a negatively charged ion. And as you can see from hydrochloric acid, the hydrogen ion has been produced which is positively charged, and also a chloride ion which is negatively charged has been produced. Let us look at another example, which is sulfuric acid. So sulfuric acid, so the same thing will happen to sulfuric acid. We know that the first thing that you're supposed to write is your hydrogen ion which is in aqueous form plus, so the other ion that is remaining is the sulfate ion, which is SO4, which is in aqueous, but the valence here of this sulfate ion is 2, so that is going to be 2 minus. Then the other example that I'll give you is that of nitric acid. So nitric acid, the same thing will happen. We're going to have a positively charged hydrogen ion plus a negatively charged nitrate ion. So a negatively charged nitrate ion, and we know that the valence number of nitrate, that's 1, so that's going to be negative. So that's how you can represent some of the different acids when they undergo ionization. But as this hydrogen is formed, it does not remain like that. It will usually combine with the water molecules to form a hydronium ion, and the hydronium ion gives the acid its properties. So let us now look at the hydronium ion. So for the hydronium ion is formed when the hydrogen ion that was formed combines with the water molecules, and the hydronium ion gives the acid its properties. So let us look at the example. So I give the example of that of hydrochloric acid. So it was in this form, aqueous. This will produce a positively charged hydrogen ion plus a negatively charged chloride ion. So this is the process of ionization, but this hydrogen which is here, it will quickly combine with the water molecules, and when it combines with the water molecules, an hydronium ion will be formed. So if an hydronium ion is formed, our equation will look like this. So we have hydrochloric acid, which is in aqueous form, plus water, and this will produce an hydronium ion which is positively charged, and it is in aqueous form, plus the chloride ion. So that's the same thing when you have nitric acid with water, plus water. So as the hydrogen ion that was formed, it will quickly combine with the water molecules to form a hydronium ion, which is positively charged, plus a nitrate ion. Here, sorry, this was supposed to be HNO3, so we have NO3 negative here, which is in aqueous form. That also applies to sulfuric acid. We have a 2 there, aqueous, plus H2O. This will produce a hydronium ion, which is positively charged, plus a sulfate ion, which is 2 negative charged. So that's all about the acids. Where you have questions on the acids, please ask in the group.